Okay, there's a little video on building the 1964 version of Robby's Heart box. It's covered in other videos clear up till 1963, and in the Twilight Zone episode Uncle Simon, Robby still had his original mechanical heart box, but by May of 1964 all the mechanics had been gutted out and the sequential light effect was put in its place. It's obviously totally silent, so that would be one of the main reasons. But another reason is I'm sure the old mechanical heart box was getting pretty worn out by then. It was getting hard to maintain, would be my guess. So where do I want to start? I think where I want to start is you can tell that this looks a little bit different than how it looked in my previous video where I was asking if anyone was interested in building it. And that's because I've made a few cosmetic changes. I don't know if I showed the back side, but on the back side I have it designed where you can either power it from a 9-volt battery, say if you just needed it to work for a few hours, or you can use one of these pen light battery holders that you can get off eBay with a connector. I made the hole big enough so that you could put the whole thing in there. This would run for days. So if you were doing a cosplay thing over the weekend, you wanted to run a long time and not worry about it, I'd go with the pen lights. It's not very thick. It could be made even thinner, but I wanted to get the LEDs far enough back where they could diffuse the light in the front, and so that was why I did that. Now, cosmetically, what I've added since the last time you saw this is I added this piece up here, which purposely doesn't fit well. We're going to talk about that. And I also went ahead and painted the whole thing, but I also went in and put, here, let's turn it off and look at it. I put a, it's called like a window tint film over the square lights so they wouldn't look so white. And the reasoning behind that, stay there, please. There we go. Let's take a look at some of the pictures. I think I can bring some up here. Let's start with this one. Okay. I'm going to make this bigger. Here you can see when they made the change, there's this big flap they put there, basically to cover where the 4 little flappers used to be. I'm not quite sure why it wasn't made completely flush, but it sticks out and we can make that more obvious with some of the other images. Let's take a look at another one here. Let's look at this one in color. And let's zoom that up. See, in this one, the little piece they put over it almost looks like a piece of cloth on a board or something. It looks red in color. Were they using it as an air vent to give the actor more air, or did it just look red because of the reflection angle? I don't know. But you can also see the cutout here. These don't look bright white. They're definitely phased in. They also added a stick-out tab on that door hopper. I didn't add the full tab on here. I figure you guys can if you want, but I did add the metal strip, which got brought in there. Let's take a look at some other pictures. Let's look at Will in this black and white scene. So here you can see how everything's kind of diffused together when it's not lit, and again you can still see that same raised panel sticking out. I made that a separate part, so if you don't want to use it, you don't have to put it on. If you do, it just glues right in. So you're starting to catch the theme here. Now let's get right to Whipple's. The brain center at Whipple's would be the one where Robby was first seen changed, so I'm sure it was the special effects guys at Twilight Zone that did it. Sticking out, it's all kind of mushed together, so I'm sure they had a diffuser across there. So you have to have a white diffuser for the light to shine against to get so it doesn't look like a hot spot. But then it looks like they put something dark, a scrim or something dark over the whole thing, so it kind of blends in. It is all kind of a different color, but it does blend in. Let's take a look, see if there's any other pictures of real interest. Here's this one here. Let's zoom that in. It's not as easy to see anything here. Here it looks like almost all three of them were lit at the same time, but it could have been a time exposure. There's a lot of shadows, so it's hard to tell if it was a dark room or what. Or it could have just been the strobe flash hitting that. I think Robby gets pretty beat up. He was a prop. He was used. So, let's close these out. I think I have, where are we at? Let's go here. On Thingiverse, I have put the files up on Thingiverse, but I really don't know for sure if they're all there are working right. It says there are 6 thing files there, but it only shows that blue thing there that is nondescript. Here, let's bring it up in the main picture. That's actually one of these lenses, which I would print. I would do this the first 1mm in white, and then I did clear for the bulk of the rest of it, and then just gave it all a sand job to kind of, you know, milk it over. But I wanted the white back there for the diffuser, but I didn't want to do the whole thing in solid white because I didn't have a translucent white, and I didn't want it to block all of the light from coming through. But anyway, what my whole point was is Thingiverse is only showing that file up in this run-up, and it's showing another one at the very end, whereas I wanted this to be the opening picture, and even though I go to edit and change it, it's not letting me do that. But it does show these other files all being there. The heart box back cover, that's this piece here. The main frame top, that's where I divided this file in half so that I could print this on my PRUSA MK3. So imagine this whole body file being cut right across here. See that seam line there? This piece will fit on the MK3 and I could print that, and then this piece would fit on and print that, and then I just glued them together. So that's referred to as the heart box top, which would be this part up here, the heart box bottom, which is this part down here. Or you can print the whole heart box as one piece if you have a larger printer. Like I have my CR10 S5, which is big enough to print 2 of these complete at a time. It's a big printer. But not everybody has them. I'd be interested to see how all you guys with your Ender 3s are able to print this. Because I don't own an Ender 3, but according to the specs online, it's only 220 by 220 millimeters. And if you're going to print this full scale, you need to be able to go 232 on the widest point, which is the width. So maybe the Ender 3s actually will print a little bit bigger than it says, or maybe you'll have to print your part vertically. Do the half one and stand it up this way and print it. Well, actually, it'd be better to put it on the bed this way and print that half vertically. Put this on the bed and print that half vertically. You might have to, instead of putting it square on the bed, you might have to go kitty corner. Anyway, I'm sure there's a way to do it, and some of you guys with Ender 3s will tell me how you figured it out. But anyway, it looks like the files are up on Thingiverse. They just haven't brought all the pictures in, and they're not allowing me to edit and change the order that they're being displayed on the front, so who knows. I will provide the link for Thingiverse in the description title below this video, so you don't need to worry about that. Where are we at now? Okay, in order to do the lights, I wanted to keep this as inexpensive as possible for me. You guys can do it any way you want. I'm going to my files here with the pictures. Basically what I decided to use, and I know I have a picture of it here somewhere. I just gotta find it. I thought I had a picture of it here somewhere. There's even more Robby ones we can look at on the heart box. Here they are. Good thing I wasn't a snake, right? So I went to the dollar store. Can you guys all see that? Is that okay on the screen? Went to the dollar store and bought these wall tap lights, $1 each, because I knew these long cobs would be a good source of lighting in there. So I got those, strip them down, took the cob light strip out of them, and they are marked plus and minus. The blue in this case was the minus and the white wire was the plus. All I was really interested in is the COB light. This is showing a sequencer, and I'm going to show you where you can get them and how to modify them, that I modified to run the COBs, because basically the sequence that they have going is flash, 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 and then repeat. So basically that's step 1, step 2, step 3, step 4. Then you want to reset the circuit so it starts at 1 again. 1, 2, 3, 4, 1, 2, 3, to get that sequence. We'll get into that. What do I want to show? I want to show, not that. I want to show that here's just an eBay auction, and you can find all kinds of them for the same board that I used. And here they're like 99 cents. You can't buy the 4017 decade counter and a 555 for 99 cents, much less all of the resistors. The red diodes that you don't need for this project, save them for something else, but you get your timing capacitor, timing resistors, timing trim pop, a little bypass cap. Kind of hard to beat that price. Now you pay a little bit more if you buy them from sellers in the US that have them in stock, but even if you paid $5 or $6 for it, that's still a pretty good deal. And like I say, we're just simply going to modify this circuit, because right now if you build this the way they send it to you, and they send you all the parts and you solder it together, it just counts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then it resets back to 1. So it's just one lead on at a time, continuous, bloop, bloop, bloop. And we're going to modify it so it was 1, 2, 3, and then the fourth one's going to go back and light this one, and then the fifth count resets it back to 1. So it's 1, 2, 3, 4, 1, 2, 3. That's the plan. In order to drive those COB chips that we bought from the dollar store, we're going to need to add some drive transistors in place of the LEDs, because this chip can only supply a couple of milliamps per pin, and we're only going to drive about 20 to 30 milliamps into those COBs. We're not going to hit them very hard. The easiest way to do that is just with a generic 2N2222A. Any generic NPN transistor will work. A 3904. See, the 2N22A and the 3904 are the most common NPN signal transistors in America. You go over to Britain and it's a whole different number. Here in America, this is looking at the rounded backside. It's emitter base collector. If we're looking at the front, it would be emitter base collector, and that becomes important when we go to hook it up. But you can see they're dirt cheap, no matter where you get them. And I mean, here you're getting 25 of them for under $2, and after you put shipping in, it's 25 for under $3. So I don't think we need to look at that anymore, and you don't need to look at that again. Just look up DIY LED sequencer. In this case, they're calling it a chaser sequencer. Some of them call it a waterfall effect. You'll find it if you look up there on eBay. So let's look at, I don't think you need my help for anything else, because you don't have to use this chip and LEDs that I did. I kind of explained to you why I did it that way. It was inexpensive and it was easy to get. You could go in there with an Arduino if you're just a programming nut and don't want to do any board level soldering and don't want to work with individual components. Personally, I think it's probably a good idea to work with board level components and learn to do it. So the kit comes to you in a bag like this. It even comes with sockets, which I chose not to use on this one because I wasn't sure if the height was going to be an issue. I wasn't sure where I was going to put the board when I was doing this. So this is your 4017. This is a decade counter. This is the one that's doing all the work. So that's pin 1, there's pin 8, there's pin 9, there's pin 16. So I took pin 15 and pin 10, and I'm going to solder them together. That's going to form that reset. So this thing will count 1, 2, 3, 4, reset back to 1. There it is with the wire across there. Go ahead and solder in the little bypass cap they give you there. It's not important, but it helps keep noise off the line to the chip. Then throw in the other components they give you. You can follow there. Everything's marked on the board. You got your 2.2K, your 47K, your trim pot, your capacitor. Mind your polarity in the capacitor. The negative side needs to go up here, positive, it goes down here. You'll notice that this chip's aiming this way and this chip's aiming that way, so make sure you get the chips in the right direction. This is your 555 timer. This is going to set the speed of the sequencing. I could have the lights flashing a lot faster or slower, anywhere you want. What we're going to do from here is, they already have it laid out so things would count 1, 2, 3, 4. We're going to go ahead and put in the 1K resistor on the 1 and 3 positions, and we're going to need to get 2 diodes. I guess I didn't look those up for you on eBay, did I? Maybe I should, so you can see what those look like. Let's go here, let's go here. You don't have to buy from eBay, I'm just doing this so you can find them. Let's go with a IN 48 diode. IN 4148. There we go. Ooh, they're going to sell you 100 of them there for $5.88. You don't need 100. Here's 30 pieces for $1.85. See, this is a very simple, they're usually called just signal diodes. They're small diodes. They're only good for up to like 100 milliamps. But we're not going to be passing anywhere near 100 milliamps into our little COB chips. Like I say, we're only going to be putting about 20 or 30 milliamps in there. So you can get any small signal diode you want. You can, even if you've got some old circuit boards or something you're throwing away in the junk, pull the diodes off that and use them. Even if they're a higher powered 1 amp diode, doesn't matter, they'll still work. Like a, you know, a 4001 or something like that, no problem. So the IN 4148 switching signal diodes, you can find someone and get them. You're gonna need to know your cathode and your anode side so you can get them put in the right way. You only need 2 of them for what we're doing. And where was our picture? Here. Here. So let's go to the next step. So next step is I put in the 1K resistor there we talked about. I put in the 1K resistor there we talked about. I put in the 1K resistor, but I only put it into the hole nearest the outside. The hole nearest the inside has that signal diode. Notice where the black band is and where that one is. And then you'll want to come over here where this says R6 and put in the other signal diode there. The black bands aiming towards each other, the non-banded end going in the hole. The other end of that 1K resistor soldering to the midpoint between the 2 diodes. What this is allowing to happen is when it goes count 1, when it goes to count 2, the signal can flow through this diode and through this resistor back to this point. Then when it goes to count 3, it goes through this resistor here. Then when it goes to count 4, it goes through this diode up to here to that same resistor point. We need the diodes. We can't just connect this and this together to that resistor because that would short out this chip, because one leg's always going to be low and one leg's always going to be high. So you need the diodes to protect the chip. Here's another view of it so you can see where to solder stuff. It should be very clear. Hopefully it's clear on the screen. Now I'm putting in the transistors we talked about, 3904s, 2N, 222As, whatever you want. Emitter goes into the hole closest out in the south side edge, because this is ground. This is called an emitter ground switch. So emitter goes in there. The base goes into the next hole in, because that ties to these resistors that we've hooked up. And the last leg sticking up in the air, that's our collector. That's what's going to drive the LEDs that we got. I decided to go ahead and put a single current limiting resistor for our COB LEDs that we got at the dollar store. In this case I started with a 220 ohm, which worked okay, but in the end I wanted the COBs a little bit brighter after I added that tint to them, so I changed that to a 100 ohm resistor. So anywhere from 100 ohms to 220 ohms will work fine. Here it is sitting inside the back tray, the switch. It's where I decided to glue in the board. There's the COBs glued in place, and this is the back of the frame showing the windows glued in. Nothing else hooked on there yet. Here it is from the front. So you can see how white it looked before. There's no sanding or painting to any of this yet. And before I put any of the window tint over it to help blend things together. And these are just pictures of what it looks like working. But you already know. You already know because there it is. So, hopefully it's something some of you can learn with, you can have fun with. And if not, then hang on, because as soon as the jumbo LEDs come, I'll be doing the video for the mechanical heart box, which I know is the one what most of you guys are interested in. And it's a lot more involved, but at least it's all mechanical. So enjoy. I think I covered just about everything I wanted to cover here. Oh, someone mentioned that the paint has been discontinued by Model Masters. The gunmetal, the 1455 that I use, this lacquer, and then the lacquer sealer. Apparently Model Masters is no longer selling the lacquer, but they do still sell a gunmetal in an acrylic. They call it 4681 acrylic. I haven't bought any yet to compare it to the lacquer color to see if it's accurate color-wise, but I'm willing, I would think that it would be. My gut instinct would be that it would be the same color. It's just instead of being a lacquer, and it's an acrylic. So that would probably be worth trying to see how it goes. I will eventually get a bottle of it and test it and see how close it is to the old lacquer. Now, it is possible that if you have a hobby store near you, they may still have this in stock. So you might want to just check and see if they still have this. The fact that they've discontinued it and that you can't find it online doesn't mean that hobby stores, which generally have kind of a slow turnaround on their stock, may still have some of the old gunmetal. And on the Model Masters display stands, or large metal stands with other stuff, these were always clear up on the very top. So look at the very top of their stand. Anything else? I think that's it for this video.